All right, so we are ready to start running some code and working with the SF package in R to wrangle and visualize spatial data. So right now, we started in this static HTML document. I'm going to move over into Posit Cloud where we can edit the Quarto document that was used to create this HTML file. And if you click on this link, this code links button over here, this will take you into the shared Posit cloud for Math 3376. And once you're in the cloud, there's also a link in the description of this video, and you can see that link over here as well. Once you are in Posit Cloud, you'll either want to download those files onto your hard drive and work locally on your computer with RStudio, or you'll want to make sure that you copy that workspace, or you'll copy that project, excuse me, into your own Posit Cloud account so that you can edit and save your work. So this is a shared document. This link takes you to a shared document. But I am in the cloud, so I'll work in Posit Cloud. And I'm working with the document called 12 Spatial Data with Simple Features. And I am working with this Quarto document in visual mode. I might switch over to source mode at times, but I think I'll mostly be sticking in visual mode so things will look a little bit nicer. And I'm also going to just resize my viewing window here so that the main pane is larger, since that's mainly what I'm going to be working with. So we can ignore this header, the YAML here. This is more giving us properties about how the document's going to look once we render it to HTML. So to get started, you don't need to run this first code cell, but if you want to get consistent output, as I am going to get, since we're going to use some randomization to pick some points, you can run this and you'll get consistent output from me. But if you don't run that, everything will run just fine in this notebook. Okay, so we talked about the intro of what simple features are and some of the packages that we can use with it. So I want to come down to the loading packages section, and we'll actually load these packages and start going with simple features. So the three packages that I'm going to load up are the SF package, the dplyr package, and ggplot2. And so we're familiar at this point with these two tidyverse packages, and we're going to learn about the SF package in this video. The color space package that can be used to access some color palettes that are also available in base R. If we use some functions or color palettes from the color space package, we're going to use the : approach for calling in those. So we'll use color space : and then the function that we want to use. And the reason why I'm not loading the color space package is it has a chords function that would, depending on the order that you load these packages, could override and mask the same chords function in the SF package, which we need. So the color space package is not as essential. So if we need to use it, we're going to use the : approach. And that's why it's commented out over here. So I'm going to run this code cell. Now we've set up the seed for randomizations with the very first code cell. We've now loaded the packages, all of the packages we're going to need in for this document. So now we're ready to get going. Okay, so we had talked earlier in the intro that simple features have two components: a geometry object and then some attribute, which is like variables associated with points in space. So I want to first talk about the geometry objects, and then we'll kind of layer the attributes on top of that. So there are kind of the two most common geometry objects that we typically use with the simple features package are points and polygons. So points are kind of the main building block for our geometry objects. and we actually construct polygons from points. And so the function to define a point in the SF package is st underscore point. And this will set up a single point. Polygon is a sequence of points. So the order of these points is important. That's going to tell us the which 2 points are we going to join with an edge. So each time I have a point in this sequence, I'm going to draw a line to the next point in the sequence. And it's going to be a bunch of connected line segments. And for a polygon, we just need that to be closed. So the start point and the end point should be equal to each other. And these are also called like closed rings, although you might think of like a ring as a curvy thing. These are made up of line segments. And you can think about things like states or countries or a single county that looks like a polygon. So some states are like rectangles and would be easy to define a polygon, and other states don't have straight edges, and it's going to require a whole bunch of points to come up with a polygon to describe some abnormal shapes. But we'll go through some code now to illustrate how we can create and plot points. So to create an XY point, I just input into the st underscore point function a vector that has 2 components, an X component and a Y component. So that's what the C1 comma 2 is. I've created a numeric vector. The first coordinate is 1. The second coordinate is 2. And I've just put a set of parentheses around this entire command so that the output would be printed to the screen. So this is going to create a point called P1, and we'll see what that looks like when it's displayed on the screen. It tells us what type of object we created and what are the coordinates, in this case, of that point. We can create an XYZ point using the same exact function, the st underscore point function. And in this case, our vector just has 3 components, an X, a Y, and a Z. So that's what I've entered here. I'm storing this XYZ point to an object that I'm calling P2. And I've got this all inside of a set of parentheses so that we just see the output printed on the screen along with the output being stored into P2. And so here is the point P2, and this is now being stored as a point Z to indicate this is an XYZ point. It's implied that the 2-dimensional point is an XY point. And then to visualize these points, we can just use the base function plot. So I can do plot P1, and that plots this point, which is located at 1, 2. So 1 is the horizontal displacement, 2 is telling us how far vertically up we move, and this plots it in a plane, a 2-dimensional plane. So there we go. It's not that helpful since we actually don't have axes here or tick marks to see our location, but we could add that if we wanted to. But here's a way to create a very basic plot of a point. And for a 3-dimensional point, if I just use the plot function, this is going to create a projection of this point into the XY plane. So we actually don't even see the Z coordinate here, which was 3. It's just plotting X and Y in the plane. So it looks exactly the same as P1, but these are different points. P2 has a Z coordinate, which is just not being plotted in this base plot function. Okay, so that is how we can define and plot points. That's kind of our basic building block. And again, the function in the SF package is st underscore point. In the next video, we'll take a look at how we can set up polygons. Okay, thank you.